In the previous video, we created a cute cat class and defined that objects of this class can have attributes like name, age, and color pattern. Let's review. Using the class keyword, we can create a class. Using the for_initToolConstructor method, we can define what attributes an object will have. By writing the class name followed by parentheses, we can call for_init to create a new object and assign values to its corresponding attributes. But there's one thing we haven't covered yet, defining the methods that an object can have. Methods represent what an object can do. For example, a cute cat object can think and meow. Defining a method is straightforward and similar to creating a regular function, with two key differences. First, it must be written inside the class, indented to indicate that it belongs to the class. Second, like for_init, the first parameter is reserved to represent the object itself, conventionally named self. Init, we said self allows us to bind attribute values to the object itself. So why do methods also need this self? One reason is that it enables us to access or modify the attributes bound to the object within the method. For example, if the number of times a kitten meows is proportional to its age, we could write it like this. A string multiplied by a number repeats the string that many times. Meow multiplied by the object's age attribute means if the kitten is 1 year old, it will print meow. If it's 3 years old, it will print meow meow meow. This way, the result of the method call changes based on the object's attributes. To call a class method, use the object, followed by a dot, the method name, and parentheses with any parameters. Just like the constructor, we don't need to manually pass self. Methods can also accept more parameters. For example, a kitten can think, and the content of its thoughts can be passed as a parameter. When calling the method, simply put the parameter value inside the parentheses. And now it's practice time. Our goal is to define a student class whose attributes include the student's name, student ID, and grades in 3 subjects: physics, math, and biology. Additionally, it should be able to set grades and print all grades for that student. You can pause and think about how to write such a class. First, to create a class, use the keyword funClass followed by the class name, setStudent, then define the for_init method. Note the double underscores. As you can see, the editor has automatically added the first parameter, phi_cell4. Since each student's name and ID are different, we can pass them as parameters and bind them to the student object. Here, even though both are called phi_name_i, self name refers to the attribute bound to the object, while phi_name_a is just a regular variable whose value is passed in as a parameter. Next, similarly, define the student's ID. For the 3 subject grades, we can define a dictionary, initially setting each student's grade for each subject to 0. If every object has the same initial value, we don't need to pass it as a parameter and can define it directly. Now, let's try creating 2 student objects. For example, create Voimite with a random ID, and then create Voimery. Now, if we use SymByObject attribute name, we can access their respective attribute values. Let's run it and see. As you can see, their individual phi_name attributes and phi_grades attributes are printed. Next, we need to define a method to set grades and change these initial 0 values. Use the divide keyword followed by the method name. The first parameter in parentheses is still dicel_phi by default. Since we want to change the grade for a subject, we need to know which subject to change and what the new grade should be. These can be passed as parameters. There's an additional logic. We only change the grade if the subject exists. Otherwise, we do nothing. So we first need to check if the subject exists. If the subject is a key in the phi self, grades dictionary, we update its corresponding value to the new grade. If key in dict can check whether the key exists in the dictionary. If it exists, update the value corresponding to the 40 key in the dictionary to the past undegraded parameter. Now, this method is complete. Let's test it by changing Mary's math grade to 95. Now, print it and see. As you can see, the grade for math is no longer 0. Next, write a method to print all the students' grades. Use the div keyword again and name it to print 2 grades. This method doesn't need any parameters, because the student's grades can be directly obtained from SAP itself. For clarity, we can first print the student's relevant information, such as their name and ID. Then, to print all grades, we can use a for loop. The for loop can be written like this. Iterate over each Wendai course. Key in the for self grades e-dictionary. Then print the corresponding subject and its grade. We retrieve the score from the dictionary using the Wendai course key as the value. Now, this method is also complete. Here, a course corresponds to subjects like physics, math, and biology, and this part corresponds to the numeric grades. Now, let's test it. For example, change Henry's physics grade and math grade, then call Suprint2 grades to print all their grades. As you can see, all the newly set grades are displayed. See you in the next video.